Hi guys. So first of all, thanks for being my guinea pigs in all of this because I'm kind of just trying to figure out as we go through the weeks. I'm also going to try something a little bit new today. Instead of going live, I'm just going to post a video and see how you guys kind of respond to that. So today I'm just focusing on 6th grade material, looking at plate tectonics and mountain building, and then looking at some studies weekly stuff. So jumping in right into plate tectonics, I'm trying to make sure that both of you get like I can say what I gotta say in less than 15 minutes a piece, so that way this gets uploaded somewhere near around the time that I was planning on uploading this. So, okay. Remember that your lithosphere is divided into different things called tectonic plates. You have your whole world, and then the world on top is split up into different moving pieces. Those pieces are called tectonic plates. And the theory that we use to describe these large movements of the Earth's lithosphere is going to be the theory of plate tectonics. There were two theories that we talked about before we left for spring break. The first one was the theory of plate tectonics, where on the top of the lithosphere, you see that the plates are moving, and we have evidence of that based off of fossils, where we found fossils from an animal that would have only been able to live in one place. So I think it was in Africa. We found fossils in Africa of that same animal and in North America. So how did the animal get from both places? They obviously didn't swim that far, so at one point in time, the two continents had to have been together. In order for them to be together and not be together anymore, they had to move. They moved through that process of plate tectonics. The movement of plate tectonics is driven from the inside of the Earth in the mantle, with that process where you have hot air rises and cold air sinks. So the same thing happens with the magma. Hot magma rises, the cooler magma sinks. I mean, granted, it's all super hot, but if it's a little bit colder, it starts coming down. And that process of just going in this circle is called a convection current. How continental lithosphere is different from oceanic lithosphere, it's right there in the name. So continental lithosphere is obviously the lithosphere that is on land, and that continental lithosphere is going to be a rougher, coarser, less dense type of rock, so such as granite, whereas your oceanic lithosphere is going to be, here's the top of the ocean. Your oceanic lithosphere is going to be below the ocean surface, so at the ocean's bottom. That lithosphere is going to be finer. It's a finer, smoother, more along the lines of basalt. So it's going to be a lot denser. There's going to be more. Remember, dense is how much stuff can we fit in a given spot. So if I'm looking at just this little tiny box here, oceanic, I'm going to be able to fit a lot more oceanic lithosphere into this than I am going to be able to fit continental lithosphere. The 8 major plate tectonics, we had done a foldable on that before we left, and that was oodles and oodles of fun. Remember, it was a 3-pager. So your 8 major tectonic plates, so you have North American, South American, Eurasian, Antarctic, the Nazca, the African, the Indo-Australian, and the Pacific. So the 2 pieces of theory that we have to support plate tectonics is continental drift. Remember, the fossils animal couldn't swim that far, so the continents drifted apart. You had continental drift and then seafloor spreading, which is basically the same thing, except that it happens underneath the ocean. Identifying rocks, or I'm sorry, not identifying plate boundaries. So remember, convergent plate boundaries, you have these boundaries, they come together. Sometimes they go up and they give you mountains. In the next section, we're going to talk about how there's different types of mountains. So if they come together and they go up, you have continental. It's the same type of density. They're going to push each other up. If you have 2 that come together and one goes down, remember that process is called subduction. So in order to have subduction, one side, it doesn't really matter which side, one side has to be a continental plate and the other side has to be oceanic. And remember, your denser plate is going to go down. So continental plate stays up, oceanic plate goes down. So that is what we're going to say about plate tectonics. That should have just been a review. I'm going to flip through that really quickly. Okay, so remember, convergent plate boundaries come together, divergent plate boundaries come apart. Divergent plate boundaries, typically they're going to happen under the ocean, and with that we're going to get some seafloor spreading, and then transform plates, they slide, and we get faults. So then jumping over into mountain building. So mountain building typically is going to deal with your convergent plate boundaries, because remember, they come together, they go up. But then we also find out that in that section that with divergent, we know that they come apart, but this coming apart is going to lead to some tension, and tension can also give us some mountain building. So starting on page 416 in your book, so let me flip over to 416 real quick because I'm looking at some notes. 416, we are looking at the different types of faults. Can you see? Okay, I can see now. So you have the different types of faults. Strike slip fault. So strike slip faults, you see that they're doing kind of this deal, so that is going to be a transform plate boundary. Your normal faults, you see that they're tension, so we're kind of doing normal faults, you see that there's tension there, so we are pulling apart while sliding this way, so you're kind of doing this, but they're still creating a gap in between them. So since there's creating a gap, you have divergent plate boundary going on. And with your reverse fault, that one, I don't have enough hands to even try to show you what that would look like, but your reverse fault, the plates are coming together, it's caused by compression, so you have a convergent plate boundary. So just to recap real quick, faults, all normal faults are caused by tension, whereas strike slip faults are caused by shearing, and then you have your reverse fault is caused by compression. Looking specifically at page 421 for numbers 4 through 6, when I was doing this on my own, there's really no way to get you where I need to, there's really no way to get you where I need you to be without walking you through the process that I had to take in order to get there. So looking at number 4, it says the basin and range province is characterized by mainly normal faults. But the question is asking you to identify what type of mountain. So you have to go back and look at a normal fault. We know that a normal fault is caused by tension. So your faults again are on 416, 417. Once you've looked at that, you need to go back and look at page 418, 419. So we know that we're looking for normal faults. Out of the 3 types of mountains that you have, folded volcanic fault block, you're looking for a divergent type of plate boundary to cause this mountain. So volcanic mountains we're going to take out, because we know that in order for us to get this type of mountain, it's got to go up. So we know that there's compression. The compression is a convergent plate boundary. Volcanic mountains are out. Folded mountains, they squeeze together, they push upward, they're usually at convergent plate boundaries. So that also takes it off the table, because it's a convergent plate boundary. We don't want that. We are looking for a divergent plate boundary. We've already taken out volcanic mountains, so that only leaves a fault block. So at the beginning, the sentence says, fault block mountains form when tension makes the lithosphere break into many normal faults. We got a normal fault, we've got tension, so the basin and range province is characterized by many normal faults, so they are fault block mountains. For number 5, the Cascade Range in the U.S. was built up by the Cascade Range in the U.S. was built up by eruptions. The only clue, because if you go back and you read volcanic mountains, there's nothing there about the Cascade Mountain. The Cascade Mountains, the majority of the ranges of the majority of the mountain ranges in the United States are in the middle of the country, and in order to have that type of deal go on, it probably was underwater at some point in time. So we have, remember, continental drift. At one point in time, the U.S. was underwater. So just those type of thoughts. But again, the only clue that you have to identify this type of mountain is that it was built up by eruptions. Not all mountains erupt. The only type of mountain that erupts is going to be a volcano. So therefore, number 5 is a volcanic mountain. And then number 6, the Pyrenees Mountains have many synclines and anticlines. For synclines and anticlines, you have to go all the way back to page 415. And synclines and anticlines, they are discussed there on 415, but the type of mountain that has synclines and anticlines comes up on page 418 specifically. And it says it in the second paragraph. In Europe, the Pyrenees are another range of folded mountains as shown below. So number 7 is the folded mountains. The last thing we're going to talk about a little bit is earthquakes, which you're going to get into more volcanoes and earthquakes next week. We know that when the tectonic plates shift, things happen. Like there is a natural consequence to your plates moving around. When plates come together, they go up and they make mountains, but even when they make mountains, that is not without some sort of consequence. The consequence we usually have from consequence may be a bad word to use because it sounds really negative, but the outcome of these plates moving is usually earthquakes. And the reason why we get these earthquakes or the ground shakes is because all of this tension, which is the big vocabulary word for today, all of this tension needs to be released. And the way that it releases is just like when you're exercising a muscle. After you've exercised it for too long or you've held it for too long, you're like wobbly. Same thing is going on with the earth. So basically we get, I guess, in a super real quick nutshell, we get earthquakes because of stress. It's the release of stress. So that's the book stuff right there. I'm about to jump into the Studies Weekly stuff. I just need to kind of turn my tripod around a little bit so that way I can show you guys what I'm poking around on the screen. And I'm back. I will probably never do that again. So it's been a lot more than a couple of minutes. I had to do some other things before I could jump back on, but I am ready to go ahead and talk to you guys a little bit about the Studies Weekly. So let's just jump into it. Okay, so here we are with our Studies Weekly. I'm gonna go ahead and log on. And then like slowly zooming out, you're going to see a bunch of different publications. In order to not have to scroll, you're going to want to click on Science, and then it'll be this publication here. Once you click on that, make sure that you have the right teacher selected, whether you do the assignment under me or under Miss Crickard. I'm still going to be able to see what you've done. So once you've gotten there, you'll go ahead and scroll. This week we are looking at, like, keep going. We are looking at Earth and Space. Now, so see Life Science, not that one. Here's Earth and Space. You are looking at Earth and Space Natural Disasters. So you'll click on Continue Reading. And then from here, you'll see that you have the 8 different articles that you are looking at, plus you have your test to go ahead and take. So let us quickly get into a couple of these things. So now that you know how to get where you need to go on Studies Weekly, let's go ahead and jump into a couple of things that might make your assignment just a little bit easier for you. So looking at the first little article, it's called It's a Disaster. We're talking about natural disasters. The thing to remember about a natural disaster is that the word natural comes from nature. So it's a disaster caused by nature. If we're looking for examples of a natural disaster, we automatically think of things such as earthquakes, hurricanes, tornadoes. Remember that your tectonic plates are the cause for earthquakes and weather is the cause for your tornadoes and your hurricanes. Examples such as oil spills, plane crashes, train wrecks, sometimes rock slides. Rock slides are both, they're both man-made and they're natural depending on the cause of that. So those examples are examples of man-caused disasters. Remember that a natural disaster has to be natural. It has to have some tie to nature. So looking specifically at severe storms, we're talking hurricanes, tsunamis, tornadoes, and just like thunderstorms. Remember that those are going to be caused due to weather, and what we're specifically looking at is going to be uneven causes in air currents. So when the earth is heated up unevenly, That's what's going to cause your storms. The 4 types of natural disasters that we need to go ahead and talk about, hurricanes, tornadoes, kind of already mentioned those 2. Hurricanes, tornadoes, earthquakes, talked about that too, and volcanoes. A big one that I left out from your natural disasters. Hurricanes have a season, and typically hurricane season is going to run from June to November. So we're looking those summer into fall months. Tornadoes. We've experienced a couple of tornadoes in the past, but nothing to where it was like extremely damaging. So tornadoes, like hurricanes, also have a scale of based off of power. So how much power are the winds driving? Tornadoes, much like hurricanes, so hurricanes are going to form over warm water. Tornadoes are going to form over warm land, and that's typically going to happen in the spring and in the summer. Earthquakes we've talked about kind of extensively when we're talking about, or when we've discussed just the earth in general. So we know that earthquakes are due to tectonic plates moving. On volcanoes, we also know that's a convergent plate boundary they've come together and they've built up and they've made a mountain. The mountain is erupted, so therefore we get a volcano. What are tsunamis? So tsunamis are often confused with hurricanes, but they're not. So a hurricane is a storm that's formed over water, whereas a tsunami is a huge wave. It's just a wave of water that crashes. Tsunamis are caused by lithospheric movement beneath the Pacific Ocean. In Vibrations and the Earth's Crust, it's a mini experiment at home. I don't have a ping pong ball. I've been thinking for a couple of minutes as to how I could go ahead and do that to at least show you. It's not possible. If it is possible, I will try to upload a video later on this week to show you how that works. So if you were to take a container, and it's kind of in the instructions, you take a container and you put some water in it, you put the pencil in, you move the pencil up and down the way the instructions say, it's going to create waves. So that's the purpose of the pencil. Looking at question number 3, how does this experiment with making waves relate to real life situation of an earthquake happening on dry land? What it really is we're talking about the vibration. When let's say that we're having a divergent earthquake. So either way, when these plates pull apart, it's the releasing of all the tension. The tension is going to cause vibration. So when your earthquake happens, it's going to cause the crust is going to shake and move violently and suddenly. Make a tornado model. If you don't have the 2 plastic, again, it's okay. I will find a video and probably link it in the description below so that way you can see that. What forms the tornado center is going to be an area of low pressure. So all of the wind is spinning around it on the outside really fast, but in the center of the tornado is going to be an area of intense low pressure. Hypothesize why, if I were to do this experiment, why would I want that bottle to be really taped tightly and carefully together in the centers? Because if I don't, all of the water is going to leak out. How does the model actually represent an actual tornado? It has to do with the low pressure in the center, so that's how the model represents an actual tornado. So it's when the water is filtering from the top to the bottom, it has to spiral through the center, and that center is going to have intense low pressure building up. Last 2 articles. First article, the first one that we're going to talk about, the upside of natural disasters. So I know that sounds kind of weird, like what good is going to come from a natural disaster? The thing with natural disasters is that, like the text says, they're natural. Earth itself is always changing. It's just really shaped right now by what humans want, but the earth itself is a living thing. So, so natural disasters can also be useful because they come from nature, is basically what we're looking at. An example of a man-made natural disaster would be controlled flooding. Farmers use controlled flooding to add additional nutrients to their land. So that would be like controlled flooding. We can't control a volcano erupting. We can control a forest fire, but any like man-made natural disaster is going to be in a very controlled environment. It's not going to have factors from nature itself. And the last thing that we're going to talk about is the Let's Investigate. You are going to have to go out to a different website, it's looking like, to answer and discuss the following questions. The Ring of Fire should not be something that's new to you. We know that the Ring of Fire is in the Pacific Ocean. It is a ring, like quite literally, of volcanoes. Okay, my Studies Weekly people, I know that your side was probably a lot shorter than the bookwork, but that's just because a lot of the stuff is just right in front of you. An easy way to kind of go about your online Studies Weekly stuff is to use a finding shortcut. So if you are on an Apple product, you would want to use Command and then F. If you are on a Chromebook, you would want to use Control and then F. If you hit those two buttons together, a little bar up at the top is going to show up, and that bar, it's going to say search or find, and you just type in some keywords and it'll pop you to, if that word exists somewhere in the article or on the page, it's going to pop you over to that spot. If you're on a phone, you're kind of out of luck in that spot. If you actually know how to do that, let me know. I'm always up for learning new things as well. Don't forget, my Studies Weekly people, that you also have the option to listen to all of the articles. So if you don't feel like reading, or you're doing something else, coloring, playing a game, whatever you're doing, you can have the website read to you, and it will read the whole article for you all the way down. Watching videos and bonus sources, those just give you extra coins to spend on your little RevRat. If you have any additional questions, don't forget, I know I didn't go over, but don't forget, you still owe me a test. If you need that reset because you felt like you didn't do so well, just let me know. Please know that Studies Weekly is cached, so what that means is anything that you do today, I will not see until tomorrow morning. The same thing goes for tomorrow. If you do something tomorrow, when I refresh it, I won't see any of your work tomorrow. I will see it on Thursday. I hope that you have a great short week. Remember that we do not have school on Friday, so that means that no work for you if you get your work done all on time and turned in. Until next time, bye.